Hello everyone, welcome back to our channel. Today we are back with one more blind 75 SD sheet problem. The name of the problem is basically the sum of two integers. The problem seems to be a bit on a easier side, but we have to do it by using the bit manipulation concept. Okay, so let's see the problem statement. The problem statement is very straightforward, like we given two integers a and b, okay, and we have to return the sum of the two integers without using the operators plus and minus. Okay. So we have example like a is equals to 1 as an input and b is equals to 2. The output will be like 3, 1 plus 2 3, but we have to do it without using plus and minus. Okay, suppose in second example we have 2 and 3, the output will be 5. Constraints are also like a and b should be greater than equal to minus 1000 to less than equal to 1000. Okay, so the brute force approach is very common, like we are restricted to from using plus or minus. We can simulate the addition using loops. Okay, suppose if b is positive, like we can increment a by 1 b times, or if b is negative we can decrement a by 1 modulo of b times. The code will be very straightforward, like if else general if else condition will be enough to solve the problem. So the approach which I told was basically implemented here. It's very easy. So time complexity for this approach will be O of modulo of b. Okay, and the loop runs modulo of b times, making this inefficient for large values. Space we don't need to think of, like it is constant only, but this method is not optimal. It is inefficient for large values, right? So what we will do is basically we will use the concept of bit manipulation, okay, for optimal approach. Okay, so we will think something which will be using the bit manipulation approach. So what we will do is basically we have a task which restricts us from using plus or minus. Okay, we can use bit manipulation to achieve the same result efficiently. Basically addition can be broken down into two parts: sum without carry, okay, achieved using XOR operator, and carry achieved using AND operator followed by a left shift. Okay, and step by step explanation I will tell you. XOR computes the sum without carry, that is 1 2, that is 0 1 and 1 0. Okay, this is binary form of it, and the output we will get is basically simple, like 1 plus 0 is 1 only in OR XOR, and 0 1 is 1, that is 3, 11 is 3 in XOR result. And if we do the and left shift of this, and identifies the carry bits. Okay, left shifting the carry moves it to the correct position basically. So this will 1 and 2 are basically here, carry is equals to 0 because 1 0 is 0 and 0 1 is also 0, so carry is also 0, and is in the result. We have to repeat the above steps until the carry becomes 0. Basically we have to dry run. We can dry run also with the example given. A is equals to 2 and b is equals to 3. So this is the binary form. Step 1 is basically carry is equals to 0 1 0 0 1 0 and 0 0 1 0. So AND operation will take care and give us the result 0 0 1 0. And A is 0 0 1 0. If we do the OR operator in 0 0 1 1 with 0 1 0 0 1 1 is equals to 0 0 1, right? If we do B, like we have to left shift B, 0 0 1 0 left shift 1 is equals to 0 1 0 0, right? Okay, so in step 2 we have to take care of carry, basically 0 0 1 and operator 0 1 0 0. So we know the concept of AND. It's basically 0 0 plus 0 0 is 0, 0 1 is 0, 0 0 is 0, then 1 0 is 0. So answer is 0. In A we can see that 0 we have to do the OR operation with these two. So basically 0 0 is 0, 0 1 is 1, 0 0 is 0, then 1 0 is 1. Okay, again we have to do the B, like we have to left shift it. So 0 0 0 0 which will become 0 only, that is carry becomes 0. Final answer is basically 5. We can see So this approach takes very less time, like time complexity will be constant. In constant number of bitwise operation will be there. So time complexity will be O of 1 and space complexity will be also constant. If we see the code, it's very simple. We are not using anything extraordinary. Like a function is get sum. Basically we need to continue the loop until there is no carry left. So we are using while loop. Okay, then step 1 is calculating the carry, that is common set bits in A and B. Carry is equals to A and B, right? Then step 2 is basically calculating the sum without using XOR. So this is the expression here. Afterwards, at step 3, we have to do the left shift carry by 1 to add it in the correct position, right? So this is the expression. Finally, it's a 3-line code. So after that, we have to return A. It's very easy if you understood the approach what we have basically used. So I hope this solution is clear to everyone. If you guys understood the solution, you can hit the like button and subscribe also, and also share it with the other students as well. Thank you.